All right, so let's now do two more examples about using variables versus using a name constant, or how to combine them together. The first example here, so this is also included in your example projects. Let me just trace that very quickly. Okay, so basically we declare some variable of type double, and then it's called radius. So now let me draw the box right away. So this is going to be the radius that I want to store double value into. Initially, it's simply 5.4. Okay, and now if I say I want to print to the console over here, so what will be the radius value? So this will be 5.4. Okay, so far so good. And this will be the first reassignment I want to do. So this will be, I will say radius is reassigned to 3.9. So this will be 3.9 over here, the same variable. So now if I try to print out the radius 2 times, right? So radius over here should be 3.9 each. You should really feel comfortable about tracing a program like this. It will be assumed, you will be expected that you will develop such tracing skills soon. Okay, and then we do another reassignment over here. It's reassigned to 9.6. Okay, so that means 9.6 will be stored over here. So now if you print it out, it will be 9.6. Okay, it's a very easy program here. Let's now move on to another example here, and we want to do some comparison here. So what I want to show you is over here. Again, you can see, so first of all, we want to show print statements involving literals or name constants only. Okay, so now in that case, name constant will never change on its value. We know that. So now let's say we got a name constant over here, pi 3.14, right? So now 3.14. What I want to show you is this. You can see we are trying to print out this particular expression. So you can see this part over here is a string literal, plus the value of whatever that's stored in pi over here. So that means this is actually going to print out pi is space and then the value of pi over here, which is 3.14. Okay, and then we are just going to print out another expression over here. So the green and the orange are exactly the same. Are we going to get the same value? The answer is yes, we're going to. So the green and also the orange, they're going to be the same output, because you can see this part over here. This part here, the string literal, is just the same, identical. And then this part over here, pi over here, is also identical. And more importantly, it's a name constant, which means it doesn't change its value. One thing you might be wondering about, which I'll explain a little bit later, just bear with me. You might be wondering, we got string values over here, and we got double value here. How can we use a plus? Okay, so there is some automatic conversion from Java that will do for you. Okay, so whenever you got plus, it's a very special operator. So plus is actually overloaded. Plus can be both for either string concatenation, or it can be for numerical addition. In the case where you simply got string together with some number, in that case, we will simply just get a string representation of the number over here. In this case, the pi, so this will be as if we actually put the pi, the value is 3.14, as if we put 3.14 over here. Okay, so that's something I will explain maybe a little bit more using more examples later. So now let's try to illustrate another example over here. So now we're going to use variables. Let me just point out to you. We are going to print out the same expression, message plus counter, and also message plus counter. Okay, where you can see the message over here. The message is simply just some string variable over here. You can see there's no final. And also the counter over here is simply some integer variable over here. Initial value is simply just 1. Okay, so now what about the value over here? For these two, you can see the value for the counter will just remain the same, right? You can think about the counter value. Initially, it's simply just 1. So here, both of them will just be counter. Okay, so we're going to have this particular string literal value being printed out first is going to be counter value is, and then with a space, right? And now what's the current value for counter? It's simply just 1. Okay, so far so good, right? So both of these expression will just be the same value that's being printed out to the console. But what about the third one over here? The third one over here, we also got message plus counter, exactly the same expression. But are we also going to get counter value is 1? No. The reason is counter over here, in between these two print statements, the counter variable has been reassigned to some other value. So that means counter over here is simply reassigned to just 2. So that means over here, we're going to get, so here the message stay the same over here. So we're going to say counter value is, and then with a space. And what's the value right now for counter? It's no longer 1, it's simply 2. So that's why you will actually get, when you try to trace a program, you will get the green versus the orange. It's actually different, right? So the point is, when you are trying to print out some expression, or later on when you try to return some expression, you want to see whether the expression itself depends on a name constant or a variable. If it depends on some name constant, then the expression value might just stay the same because the constant doesn't change. On the other hand, if the expression actually depends on some variable, in that case, the variable value might change, for example, from 1 to 2. In that case, this value here will just be 1, and this value here will just be 2, right? It's different. Okay, so that's the second example I would like to talk about. Okay, let me go back to the slides. You may have known this maybe from your previous programming courses, but that's okay. I don't assume any Java knowledge for everybody in the class. So in case you're an absolute beginner to this course, hopefully you're still feeling comfortable about the pace. Okay, so now if you go to the next one, this is simply just the example that I talked about. Okay, so you can simply just see the clean version, but you can also refer to the trace version over here to see more insights. The final, okay, so this slide over here is just about some naming convention. Whenever you want to create names for your variables, name constant, or classes, there are certain conventions for you to follow. I don't want to waste your time by reading off the slides. I'll leave this slide here for you to read. Okay, so just for example, for the class, it should be capitalized, and then for compound words, every compound word should be capitalized, right? And also for variable, the first word should be lowercase. But starting from the second word, it should be capitalized. So that's kind of the naming convention. You're not going to get any compile time error if you don't follow the convention, but I would say follow that because that's kind of what Java programmers assume you will actually follow. I'll let you go over this particular slides for the details, right? Let me talk about 2 more points about for this video. There's some common mistake for variables over here I want to talk about. I kind of talked about them already, maybe for the second one. Okay, mistake number 1. The same variables is declared more than once. Over here, you can see here we have declare integer and integer. We want to declare the integer data type twice. One for counter, the other one for counter as well. So we got clashes on the names. So this is simply not allowed, right? So you just cannot use the same variable name more than once. How can we fix it? So here I put 2 possible fixes for you. So let's see the first one. The first one, you can only keep the first declaration, meaning that maybe what you meant to say was maybe integer counter is initialized to be 1. So that's okay. And then maybe for the second one, you simply meant to reassign the counter to be 2. So what's happening here is you initialize the counter simply to be 1. And then when you do this particular reassignment, you simply reassign that to 2. This is one possible fix if that's what you meant. Another fix you can do is you simply declare a new variable. For example, you can say integer counter is initialized to be 1, and also integer, maybe I'll just give a different name. as long as it's not counter. Maybe counter 2 is assigned to 2. So what's happening over here is we got one integer box, counter, initialized to be 1. We got another box, so here this will be counter 2, initialized to be 2. So you can see we got two possible fixes, but which one to adopt is kind of up to your need. Either you can reassign the same variable multiple times, or you simply just got separate variables or separate placeholders for the values. So that's the first common mistake. Let me talk about the second one. The second common mistake, which I already talked about, is when you try to use a variable before you declare it, right? Every time you want to use a variable, must declare that first. So let me show to you. Let's first identify all the uses for this particular variable called counter. Okay, let me highlight it in blue. You can see this is usage number 1. So we are trying to print out the value for the counter variable. And then this will be usage number 2. We are trying to reassign the value for this counter. And this will be usage number 3. We are again trying to print out the value for counter. So now we want to see which one is invalid. Hopefully you can see right away this one here is actually invalid, because whenever you're trying to use this variable here, you're expecting its declaration beforehand. But now in this case, it's actually after this line did we actually have this particular declaration over here. So this is the declaration. So this part here is the declaration, which is too late. Okay, so this is the declaration. So this declaration will only make the usage number 2 and also usage number 3 valid, but not for usage number 1. Okay, so just make sure every time before you try to use any variable, make sure it's already declared in the context. You should remember sequential composition. So whenever you're trying to execute the program, it's going to go from the top to the bottom. So you want to make sure if you're trying to use a variable at this point, it must have been declared some point earlier, for example over here. But if that's declared, but if you're trying to use a variable over here, but you only declare that, let's say, after that, so this will not be okay. So that's conceptually what's happening over here. Alright, so let's now go back to the slides. So we have already covered the two common mistakes about variables. And the next topic we're going to cover will be about expressions. So why do we need expressions? So you can think about there are two scenarios where expressions can be very useful. Scenario number 1, when you're trying to print a value to the console by using system.out.println. And scenario number 2, when you're trying to assign a value as the source to the targets in the context of some variable assignments. So now for the values over here, it can be simple value like 23, some literal, or it could be some variable I or J or S, right? But if you can use expressions to really denote the value, it actually would be very useful. We'll see exactly how that happens. But for now, just remember there are two scenarios where you can use expression. Number 1, when you want to print some value to the console using system.out.println. And scenario number 2, when you're trying to assign some value on the right-hand side to some variable. So these are the two scenarios. Okay, an expression is simply a composition of operations. Let's see some example. I got plenty of examples to show you. An expression may be, so type correct. So I promised that I would need to talk about type correctness. So there you go. Whenever you talk about operations, you want to see whether or not the types of the operands are actually compatible with the corresponding operator. For example, if you talk about multiplication, it's a binary numerical operator, which means both operands must be numbers or integers or doubles, right? It cannot be string. For example, you cannot multiply two strings together. So type correct is a very important concept, and for now we only worry about type correctness for numbers or strings, the easy one. Later on we may want to worry about type correctness for objects, but that's later for the course. Let's see the first one. Is this type correct? Think about the different operations we are doing. So the fact that we are using parentheses, so that means this must be evaluated first. So in that case, 1 plus 2. plus in this case can either for string concatenation or it can be for numerical addition. But apparently both sides are simply just numbers 1 and 2. So this makes sense. We'll simply add up, going to add up 1 plus 2. And then this part here will also be evaluated first. And then 23 modulo 5. That makes sense. We want to get the remainder. By the way, what would that be? 3, right? And then once you get a left-hand side is a number eventually. Right-hand side will also be a number. And now in the middle, we're trying to use a multiplication. For the multiplication operator to be type correct, we must make sure both operands must be numbers. So this is number and this is number. Okay, hopefully that makes sense to you. So this is type correct. What about this one here? This is also type correct. Again, we're using the plus, which is overloaded, but now the left-hand side is actually a string literal, and the right-hand side is just another string literal. So now the plus will simply just concatenate the two strings. So that makes sense. So that's also type correct. Let's see some examples where it's not type correct for the expressions, so you can contrast. Why would this not be type correct? Why can we not do 46 modulo 4? Notice that this is modulo correct, so both operands must be numbers. Is this a number? Apparently it's not. It's a string literal. So 46 is enclosed within double quotes, so it's a string. You cannot say a string modulo another string. It's simply not going to work. So that's why it's not type correct. So what about this? This one is slightly more complicated. I do have the explanation in the slides, but let me demonstrate to you how you can decide for this particular given expression over here. Again, you can see we got parentheses over here, which means this part must be evaluated first. And also we got parentheses over here, which means this part must be evaluated second, before we can consider the middle multiplication, right? As I said before. Let's take a look at the first one. It's a plus, and then we can see this is a string. This is a string. And then we're trying to say string plus string. Is it allowed? Yes. It will be for concatenation. Okay, so now overall the blue part, the first operand, the left operand for the multiplication will just be a string. Okay, what about the right hand side? So the right hand side over here, wow, you might be able to see that it's already not type correct, because in order for multiplication to be type correct, both operands must be numbers, but the left hand side is already a string, even though this sub expression is actually type correct, but doesn't mean it's not useful, because in order for the overall expression for multiplication to be type correct, this must be a number. Okay, I'll write it down in just a moment. And then for this one here, this sub expression over here, so 46 modulo 4 is actually type correct and is going to be a number. So now we're going to multiply a string by a number, so it's not type correct. So I'm going to write it down over here. So you can say overall not type correct, even though the sub expressions, part of it, sub expressions, just to save some writing, so sub expression 1 and this is sub expression 2, right? The two operands for the multiplication. The sub expressions 1 and also 2 are type correct, right? This is type correct. This is type correct. However, since you're trying to combine these two using the multiplication operator, so that is not type correct. Let's consider more examples, shall we? So now I got different examples over here. I got quite a bunch. I got 1, 2, 3, 4, 5, 6, 7, and 8. I would suggest you pause the video and think about for each one of them. Are they type correct? For each one of them, if it is type correct, what will be the value? If it is not, why not? Right? Pause the video and think about it. Okay, assuming that you have paused the video and thought about it, let's see one by one. The first one here, actually we have seen that already. We are trying to do 1 plus 2. that one will just be 3. As long as you can calculate the value, so that means it is type correct. So 23 modulo 5, you should get 3. 3 multiplied by 3, it will be 9. So yes, it is type correct. So what about the second one? Second one, you're trying to use plus. So now, because both sides are simply just string, so it will be a concatenation, right? It's going to be a concatenation. So it's going to be type correct. I'll say yes. So it's going to give you a string, hello. So this is empty space over here. Hello space world. Okay. What about the third one over here? It doesn't seem to be type correct, does it? Multiplication, which means this must be a number and this must be a number, but apparently they are not. They are string literals. So no. So you can see because multiplication is expecting integers on both, but this is a string and this is also a string. So that's the rationale. What about this one here? Similar. We want to do modulo over here, so that means both sides must be integers. But this is a string literal. This is also a string literal. You cannot take modulo of number of some other number, right? So this is also no, right? And the rationale, I already explained it. So what about the next one? This will be very interesting. And I promise in the previous example that I'm going to give you more details. I can tell you that, first of all, this is going to be type correct. Yes. Okay, think about what's going to happen here. Plus is a very special operator. So now when you say hello and then plus 3, if you think about these two, basically what's going to happen is string can either be a numerical addition or can be a string concatenation. So Java is being very tolerant. It will try to see which one works, right? So now you got a string here. As long as one of the operand is actually a string for the plus, it's going to be concatenation. So what it is going to do is it's going to say hello, and then it's going to concatenate, going to append 3 to the end over here. And then that's the string you will get so far. So far up to here, you actually get a string. And then you'll try to apply another concatenation, right? So you can see a string hello 3 plus the 2. So that means hello 3 and then 2. Notice that it's not going to be hello 5 because the 3 and the 2 over here is going to be concatenated separately. So that's an important point I'd like to point out. Think about this plus over here and also this plus over here. They are no longer numerical additions. They are simply just concatenation. The question would be, what if I really want 3 plus 2 to be evaluated? In that case, you would need the parentheses to really force the order of evaluation, which is exactly the next one. So the next one over here is also type correct. So now you can see we got parentheses over here. So that means we're going to evaluate 3 plus 2 first. And that one is going to give us 5. And now the plus over here, because the left-hand side is already a string, so it's going to do hello and a space and then 5. Okay, so I really want you to, oh, of course this is type correct. I really want you to contrast this one over here and also this one over here. And the difference, of course, is about the parentheses over here, right? I'll let you to contrast that. And of course, you are encouraged to try this out in Eclipse as well. So let's see the final two. What about this one here? Well, basically what's going to happen is this. You can see we got plus, right? And this part is already a string. So that means no question about it. It's going to be hello, and then we're going to have 3 over here. But now, you can see that we got also 2 times 2. It turns out Java compiler would be very smart to figure out, okay, since you're trying to do concatenation, first of all, the plus over here must be concatenation because one of the operands is already a string. Okay, let me write it down first. The plus here and the plus here must be concatenation. So now, if you want to concatenate, you want to concatenate with some string, right? So now, the 2 times 2 can really make some string out of it because 2 times 2 is going to be 4. And you simply take the string representation of 4. On the other hand, an alternative to work this out is going to hit the wall. because if you think about, if you want to calculate only like this, hello 3 and 2, pretty much like how you did it before. But this one here is going to give you hello 3. But hello 3 cannot be applied to the multiplication. So this is going to reach a dead end, right? So that's why Java compiler knows about such pattern. So that's it is going to apply the heuristics. Let me say it again. This plus over here is going to be concatenation. Since it's concatenation, it knows that if you simply say concatenated with 2, then multiply by 2 is going to hit the wall. So that's why it's going to say concatenated with the result of 2 times 2. So it's really as if you actually put the parenthesis over here. So these two are equivalents. Either put it or don't put it. All right, let's see the final one. Is this type correct? The previous one, of course, is type correct. I'll say yes over here. And the final one, it is actually not type correct, because now you can see the plus over here is going to be string concatenation. There's no question about it. So that means you're going to get intermediate expression over here, hello, space, and 3. However, now you're going to apply multiplication. That's a problem. If you're going to say multiply by 2, this doesn't make sense, because multiplication expect both operands to be integer. Okay, so this will be no. All right, so I got 1, 2, 3, 4, 5, 6, 7, 8. I got 8 examples over here. Try to study them, try to understand exactly what's happening over here. Apparently, these final 4 are trickier than others. I would suggest, if you think about other possible expressions you would like to try it out, try on the Eclipse. I do encourage you to do so. Final example to look at, which pretty much we have seen already. So now, the pink one, is it type correct? Well, hopefully you can see that it's not, right? This part over here, let me try to use a different color. This part here, it is type correct. Okay, I'll say this is type correct. Okay, so it's going to give you 2. Okay, if you don't know why, how to calculate remainder, you can speak to me privately. I will show you. Okay, so this part is actually 2. So now it cannot, and this part here, string concatenation, is going to give you la la land, and also land. And now, can you actually multiply string together with 2? No, you cannot. So no, not type correct. Even though the sub expressions over here are type correct, but if you're trying to put them together using the wrong operator, then of course it's not going to be type correct. What about the next one? The next one here, a similar reasoning over here, but now you can see this part here, it is type correct. Okay, this is type correct, so that will give you 2. And also this part over here is also type correct. It's going to give you the string, the la la land over here. But now you're saying plus over here. So now, what would that plus be? Well, again, it's being overloaded. So now, because one of the operands is simply a string, so it's going to be concatenation. So overall, you're just going to get la la land 2. That's what you will get. So I will put yes. It is type correct. All right, so we have seen many examples about how you can analyze expressions and also type correctness. So we will definitely revisit this concept throughout the semester about how you can build complicated expressions. Okay, if you go back over here, so we talk about all the examples, especially for the York University that we spoke about type correct versus not type correct.